Today, we're delving into the practical world of conduit work, specifically focusing on the tools, techniques, and terminology involved in bending and cutting various types of electrical conduit. It's a field that requires precision and a good understanding of the materials at hand. To guide us through this, we have Alex, who has a deep understanding of these processes.
Thanks, Gemini. It's a subject many might overlook, but the proper manipulation of conduit is fundamental to safe and efficient electrical installations. We'll start with the basics, like hand benders.
Hand benders are ubiquitous in this line of work. What are their primary applications and limitations? I understand they're quite versatile, but for smaller conduit.
That's right. A hand bender is really suited for conduit up to 1¼ inches in diameter. They're essential for making various bends in smaller conduit, covering trade sizes from ½ inch to 1¼ inches, or metric designator sizes MD16 to MD35. Most are designed to bend both rigid conduit and electrical metallic tubing, or EMT, of corresponding sizes.
So, a single hand bender can be used for different types of conduit, even if their nominal sizes differ slightly?
Exactly. For example, a single hand bender might bend 3/4 inch EMT, which is MD21, or ½ inch rigid conduit, which is MD16. The next size up could handle 1-inch EMT, or MD27, or 3/4 inch rigid conduit, MD21. This flexibility exists because the corresponding sizes of conduit have nearly equal outside diameters, which is what the bender interacts with.
That's a practical detail. Now, how does a hickey fit into this picture? I've heard that term, but it seems to have a more specific application than a general hand bender.
You're right to distinguish them. A common misconception is that a hickey can bend any type of conduit a hand bender can, but that's false. When you use a hickey, you're not just forming the bend, you're actively shaping the radius. It requires more manual control. The critical point is that hickeys should only be used with rigid metallic conduit, or RMC, and intermediate metallic conduit, IMC, because they provide very little support to the walls of the conduit during the bend.
So the lack of wall support means softer conduits would likely collapse or kink. That makes sense. Let's move to some key terminology. What's meant by take-up in the context of bending?
The term for the amount of conduit the bender will use to form a bend is take-up. The desired rise is the height of the stub up. Take-up distances are usually listed in the manufacturer's instruction manual for the bender, and it helps you calculate where to start your bend to achieve a specific rise or stub up.
And offset is another common term. What does that specifically refer to?
An offset requires two equal bends of less than 90 degrees. It's used to change the elevation of a piece of conduit, allowing it to go over or under obstructions, or to ensure proper entry into electrical boxes or cabinets.
That sounds like a standard procedure. What about navigating a larger obstacle, something a simple offset wouldn't handle?
For a larger obstacle, you typically use a 4-bend saddle. These can be challenging because all 4 bends must be aligned precisely on the same plane. It's essentially 2 offsets formed back to back. Taking the time for accurate layout and execution pays off, preventing wasted material or having to scrap the whole piece and start over.
I can imagine the frustration of scrapping a piece if the bends aren't perfect. Beyond bending, cutting conduit is also a regular task. What tools are used for cutting RMC and IMC?
A pipe cutter is ideal for RMC and IMC. The process involves securing the conduit in a vise, marking the cut, and then placing the cutter over the conduit. You tighten the cutter, rotate it so the blade pulls into the conduit, and then tighten it a 1/4 turn for each full rotation. Adding a few drops of cutting oil helps, and when the cut is almost finished, you stop and snap the conduit to reduce the internal ridge.
That's a detailed process. And once it's cut, reaming is necessary, right? What if a dedicated reamer isn't available?
Reaming is essential to remove burrs and smooth the edges after cutting. If a conduit reamer isn't available, you can use a half-round file, ensuring the tang of the file has a handle attached for safety. For EMT, the nose of diagonal cutters or small hand reamers can work.
So different conduits require different cutting methods. What about PVC conduit?
PVC conduit is normally cut with a handsaw. For 2-inch and larger PVC, using a miter box helps ensure square cuts. For smaller diameters up to 1.5 inches, a PVC cutter is very efficient. After cutting, a pocket knife can deburr the ends.
That sounds much simpler than cutting RMC or IMC. But I've heard PVC also involves unique considerations, especially regarding solvents and cements.
Indeed, while PVC is easier to cut, the solvents and cements used to join it are hazardous. You must wear gloves and eye protection, follow product instructions carefully, and always ensure the area is well ventilated. It's not a process that should be taken lightly. You must wipe all contacting surfaces clean and dry, apply cement to both pieces, press them together, and rotate about a half turn.
That's a critical safety warning. Let's shift back to bending. We've discussed offsets and saddles. What about a 90-degree bend?
A 90-degree bend is also called a stub up, referring to the rise in a section of conduit at that angle. This is arguably the most basic bend. Before making a 90-degree bend, you absolutely must know two measurements: the desired rise, or stub-up distance, and the bender's take-up distance. These are crucial for accuracy.
So precise measurements are key. What about the concept of developed length?
Developed length is the actual length of the conduit that will be bent. It's the physical length you'll measure out and then manipulate with the bender.
And segment bends and back-to-back bends?
A segment bend is a large bend formed by multiple short bends or shots. A back-to-back bend consists of two 90-degree bends with a straight section of conduit between them, all on a single piece of conduit.
What about concentric bends and gain?
Concentric bends are 90-degree bends made in two or more parallel sections of conduit. The radius of each bend is progressively increased for conduits further from the inside bend. Gain is the distance saved by the arc of a 90-degree bend, effectively the material that would be added if the bend were a sharp corner instead of a curve.
The precision required sounds immense. What's the key to accurate bending with a hand bender?
Constant foot pressure on the back piece combined with force on the handle. Hand benders are designed for this two-point application of force. You must keep the conduit on a stable, firm, flat surface throughout the bend. Allowing the conduit to rise or bending on soft ground will distort it.
And after cutting and reaming RMC or IMC, threading is usually next. What tool is used for that?
Typically, a ratchet threader is used. Only RMC and IMC have walls thick enough to be threaded effectively, making them suitable for secure, threaded connections.
We often talk about bends in terms of geometry. How does a right triangle relate to conduit bending?
A right triangle is fundamental. The side directly opposite the 90-degree angle is the hypotenuse. On the job, when you make an offset bend, that offset forms the hypotenuse of a right triangle. Understanding this relationship helps in calculating precise bends.
That brings us to parallel offset bends. How do you ensure the ends aren't uneven, especially when dealing with multiple conduits?
To prevent uneven ends with parallel offset bends, you need additional information: the center-to-center spacing between the conduits and the tangent of half the offset angle. The amount to add to the bend is calculated by multiplying the center-to-center spacing by the tangent of half the offset angle. This ensures consistency across multiple parallel conduits.
Finally, we touched on PVC earlier. What's involved in bending PVC conduit itself?
Bending PVC conduit requires a heating unit. You must rotate the PVC regularly while it's in the heater to ensure even heating. Once heated, you can bend it by hand. Some units use electric heating elements, others use liquid propane. After bending, a damp sponge or cloth can be used to help the PVC set up faster.
It's clear that while the tools might seem straightforward, the techniques and considerations for each type of conduit are quite specific. Thank you, Alex One, for illuminating the intricacies of conduit bending and cutting. For anyone who found this conversation helpful, consider sharing this episode with a friend or colleague.